Hello my friends, today we want to talk about multiplexing capability of OLA-PCR technique. As you know, I mentioned in another video, this technique is for detecting point mutations. In this technique, we have a pair of probes. Imagine a situation where we have a normal allele and a wild type allele. As I mentioned in another video, we have a probe that is fully matched to the normal allele who is not a perfect match for the mutant allele. As you know, when we done the PCR step in OLA-PCR, we realize the genotype by compressing with a controlled sample originated from a healthy normal people. The comparison occurs in fragment analyzer equipment that could measure the size and amount of the fluorescently labeled PCR products. As you know, the amount of PCR product between the test sample and control sample elucidates the genotype of our test. But to detect more than one point mutation, we can use the different size for our PCR products. Imagine a situation where we want to detect 2-point mutation, 2 separate point mutation. We can use different size for our PCR products by adding a fragment to one of the probes. When we use fluorescently labeled primers to produce PCR amplicons, we have different size of PCR fragments. For example, in this one, 25 base pair, 25 base pair, 25 and 25. We have a PCR product with 100 base pair size. But in another one, we have a bigger PCR product. And the fragment analyzer equipment could detect these PCR products in separate graphs. For example, 100 base pair and 125 base pair. And in the healthy controlled sample. So we could design many probe pairs to detect many mutations. For example, more than 50 mutations in just one reaction.